Hello everyone. Now we are going to learn about filters, electronic filters. What is an electronic filter? An electronic filter is a frequency selective circuit that passes signals of specified band of frequencies and attenuates the signals of frequencies outside the band. We all know that electronic filter, it has to allow certain set of frequencies and it has to attenuate some frequencies, which is also known as a filter. Okay, so this is the definition of filter. Now let us see how these filters are classified. These filters are classified into different types. First one, when we consider depending on the signal processing technique, we can say these filters are classified into two types: analog filters and digital filters. Analog filter is a filter which filters analog signals, which process analog signals. And what are the digital filters? Digital filters also process analog signals with digital techniques. Coming to the frequencies used, the filters are classified into two types. One is audio frequency filter, second one radio frequency filters. Similarly, based on the components used, these filters are classified into two types, and they are passive filters and active filters. Passive filters, they use passive components. Active filters, they use active components. What are the passive components? Resistors, capacitors, and inductors. These are the passive filters. These are the passive components, and the filter that uses these passive components is called a passive filter. And active filters use active components along with passive components. For example, in this course, we are going to use the active component, which is an operational amplifier here, along with few passive components like resistors and capacitors. Now, this topic deals with the active filters. Before going into the details of active filters, let us see what are the passive filters and what are their disadvantages. And passive filters work well for high frequencies, that's okay. But at audio frequencies, the inductors become problematic. That means they become large, heavy, and expensive. And therefore, that becomes a disadvantage of passive filters, because always we try to design circuits which are very portable, but when the component becomes large and heavy, it is a disadvantage. And when the inductor becomes large and heavy, of course, it is also expensive. And coming to low frequency applications of these passive filters, more number of turns of wire must be used, which in turn adds to the series resistance regarding inductor's performance. That means, let me show you, right? So when we say inductor, okay, now here more number of turns are required, and this increases the resistance of the circuit. Therefore, this is the disadvantage with passive filters. Okay, now let us see the advantages of active filters. Let me take my pointer here. Right. So active filters. Active filters use op amps, as I have just mentioned. Op amp as active element and resistors and capacitors as passive elements. And now here we can have inductorless operation. When the inductor is not present in the filter circuit, it becomes smaller, right? So by enclosing a capacitor in the feedback loop, inductorless active filters can be obtained. That is the biggest advantage with the active filters. Now, if we see the clear-cut advantages of active filters, we can see advantages of active filters: gain and frequency adjustment. We can have good control over gain and also frequency. When op amp is connected in closed loop configuration, we can have good control on the gain of the op amp. Whereas an op amp is connected in open loop configuration, gain is very high and we cannot have any control. Therefore, output will have either transistor that is at the available at the output will operate at the saturation levels, either at plus Vset or at minus Vset. Therefore, with active filters, with the feedback, it is possible to have control over gain and also frequency adjustment. And next advantage is no loading problem because we are using operational amplifier and op amp has very high input impedance, and because of that we will not have any loading effect. Then coming to the cost, active filters are more economical because only inductor doesn't present and only resistors, capacitors and operational amplifier we are going to use. Therefore, compared to passive filters, these active filters are cost effective. That means they are more economical. And it is possible to achieve higher power output. And then we also achieve sharp cutoff characteristics without inductors. And also these active filters are available in IC form, right? Single chip universal filters are available and they can be configured for any type of filter or any type of response. So thus we have some advantages of active filters over passive filters. Then when we see the applications of active filters, these are used in radio, television, and then radar applications, space satellite applications, and biomedical applications. Now we know these filters are available in different groups. That means some commonly used active filters are low pass filters, high pass filter, band pass filter, band reject filter, and all pass filters. Now, if we see the review of all these filter types and responses, mainly the type of filters are low pass, high pass, band reject, and band reject or band stop and all pass filters. And when we say pass band, their attenuation is 0 dBs. And in the at critical frequency, we have 3 dB attenuation. And in stop band, there will be roll off of 20 dB per decade for first order filter. Okay. And now coming to the practical filter responses. Okay. Now we can see the bandwidth of the filter, that is upper cutoff frequency minus lower cutoff frequency. And of course, it is bandwidth always, a range of frequencies. And coming to filter responses that are commonly used practically, we have Butterworth response, Chebyshev, and Cavour. And coming to Butterworth, we have a flat pass band and a flat stop band. Let me show you this. Let me take my ballpoint pen. Right, this is pass band and this is stop band for a low pass filter, right? So this is pass band. This pass band characteristics are flat and stop band characteristics are also flat in Butterworth filter. So therefore, it is also called as, let me take my pointer. It is also called as flat filter. Okay. And in Chebyshev response, ripples in pass band and flat stop band. So here we do have ripples in pass band and flat stop band. That is called Chebyshev response. These are the practical filter responses. Then we have curved filter in which both in pass band and also in stop band there are ripples. And in our discussions, in future discussions, we are going to discuss about Butterworth filter only because of its simplicity in design. Okay. Now let us see some of the frequency response of major active filters. Okay. Of course, because you have studied already these passive filters, and at the time of passive filters also we have seen low pass filter, all this, and therefore I'm showing all the frequency responses in the same slide. So this is a low pass filter. So low frequencies are allowed to pass and high frequencies are attenuated. Okay, that is called low pass filter frequency response. Coming to high pass filter, low frequencies are attenuated and high frequencies are allowed to pass freely. And this is the band pass filter frequency response. A range of frequencies are allowed to pass freely and other frequencies are, that means frequencies outside the band are attenuated. Okay. And from here you can see this is the frequency response of high pass filter and this is the frequency response of low pass filter. Therefore, high pass filter plus low pass filter, combination of these two gives wide band pass filter. Similarly, band reject filter frequency response, this one, and this is low pass filter response and this is high pass filter response. So when we cascade low pass filter and high pass filter, we can design a band reject filter. This band reject filter allows certain range of attenuates certain range of frequencies and allows frequencies outside this band. And coming to all pass filter, and this is actually this has some specific applications in telephone lines. Okay, with some delay, all the frequencies are allowed to pass freely. So like that, we have different filter frequency responses. And thank you. And you please subscribe my channel for more videos on these filters.